Hello everyone. In this video we are going to talk about something about current. Okay. Now when we in general say current, the first thing that clicks our mind is the, the current which flows through the wire and a bulb glows or my fan starts moving is what we are used to saying as current. But in physics, current means something else. Current means, like if you can see here, water is flowing. Okay, we say the word water current. Okay, means either the water is flowing slowly or fast. But the one thing which is flowing is water. The flowing of water is called as water current. Same way, if you can see here, the leaves of the trees are moving or blowing because of the wind which is blowing with a high speed. So here the wind is flowing. So the current in this context means anything which is flowing. Flow of something is called as current. Okay. So the water current means flow of water and wind current means flow of wind. In that case, then what is flowing in our electricity or electric current? So from now on, we will not refer electricity as current in general way, but we are going to refer it as electric current. So what is flowing inside the electricity? Because just now we said that current means what? Something has to flow. In water current, it's water which is flowing. In wind current, it is wind which is flowing. So in electricity, the thing which is flowing inside this wire and reaches the bulb and the bulb starts glowing is nothing but the electron. Okay? Electrons flow. Therefore, it is electricity. Okay? Electric current. As the flow of electrons make up the electric current. Okay? So in electricity or electric current, we have done you would have done in many experiments, you have used a battery, wire and different motors, especially boys would have done it. Especially in your science projects where you have to just do some motor, use it to run at a small fan or something or the other, which you use related to electricity, and you have done some of the other models in your 8th standard or 9th standard. Okay, so I'm going to quickly show you the different components which are required for electric current or electricity, and then I'll explain them one by one. So this is the battery. You all have seen a battery. Okay, now we know that the battery has a positive and a negative terminal. Here the positive terminal or the positive side is going to be the orange color and the blackish part is the negative terminal. So this is my battery. Now a circuit or let's say a building up, like I want a bulb to glow. So let's take a bulb. Okay, and I want a switch to switch it on and off. So let's say I'm taking this switch. Okay, now can this be glowing together, work together? No, we need some wires to connect, right? So let's take some wires and I'm going to connect this using a wire. So you just be patient with it and be with me. Okay, so let's quickly connect them with wires. Okay. Now, if you see, I've connected every end with the wire. So if you see this, the battery is connected to the switch is connected to the bulb, and then the bulb is directly connected to the battery. Now why is this bulb not glowing? Because yes, the switch is open. The switch is not on, it's in off, means it's open. So let's close it. So is the current flowing? Yes. Now if you can minutely observe, there are these blue color balls which are moving throughout this wire, going to the bulb and passing through the key and then back to the battery, right? So these blue color balls that you see are nothing but electrons. So can you say that it's the electrons which are flowing in this particular we call it as circuit. Okay, in this circuit, so the bulb is glowing. So if I open this, there's no glow. If I close it, again what is happening? The electrons have a continuity and they are flowing continuously in a closed path. So my bulb is glowing. Okay. So again, the electrons are moving in a continuous closed path through the circuit. Thus the bulb is glowing. Okay, so this is called as the electricity, or in normal term as electric current, the flow of current, electrons per unit time. How many electrons are passing through this circuit per unit time can be said as electric current or electricity. Okay, so does that experiment, or does that give you a clear picture when I said flow of electrons is nothing but electric current? Okay. So electric current. What is electric current? Electric charge flowing through a conductor is called as electric current. What is a conductor? The wire that we connected, right? A closed and a continuous path is very important for electric current to pass through. This is how I had connected the circuit. If you remember, I had connected two batteries, but in this picture I've taken one battery connected to a key, and then that is connected to the bulb. And if you remember, the blue balls are nothing but they are representing the electrons. So this is closed continuous path, therefore current is flowing through it. Now if the circuit is broken, means when my switch was open or when the switch is off, the bulb is not glowing, which we saw in that particular arrangement. When I had kept it open, there was no current flowing, the blue balls were not moving, and the bulb was not glowing. The moment I switched it on, and I closed this, the movement started for the electrons and the bulb started glowing. Okay, so a circuit is broken anywhere or the switch is turned off, then the current will not flow through it and the bulb will not glow. Okay, now direction of electric current. Okay, electric current was considered to be the flow of positive charges. The direction of flow of positive charges was taken to be the direction of electric current. Why we are mentioning this is because when electricity was being invented, if you remember the experiment where the scientist had connected a key with the thread of the kite, the wire of the kite, and he was flying a kite during a lightning stormy day. The lightning hit the kite wire, and then that passed through the key, and then the person experienced electric shock. So that's how the story goes back, how electric current was invented. And during the time when electric current was invented, nobody knew that it was electrons which was flowing around it. And maybe little 60 to 70 years later, we discovered that every single matter is made up of atoms, and atoms are made up of electrons, protons, and neutrons. So they didn't know what was flowing inside. So they just conventionally took that. They always believed that it was always from positive to negative. So that is what the current flow we always took. But if you look in this picture, this is the positive, right? So current is shown through the arrow. Can you see the red arrow which is moving from positive through the bulb and going back to the negative? Same way, the blue balls are also moving out from the positive terminal of the bulb battery and coming back. So the battery has a positive, which is plus, and minus. This is a plus and a minus. So conventionally, we believe that the current is flowing from the positive terminal towards the negative terminal. But now, as per definition, okay, so conventionally what we normally take is the direction of the electric current is taken to be the direction of the flow of the electrons. Okay. That means the current flows from the positive terminal to the negative terminal. But in reality, it's the other way around. Why? Because electrons are negatively charged particles, and negative charge will always get attracted towards the positive. So in reality, inside the circuit or inside the wire, the current is flowing from negative terminal to positive terminal. Okay, but still we follow the conventional method because it's been discovered and we are practicing it for such a long time, so we don't want to change it. Okay. Next is electric circuit. Electric circuit is a closed and a continuous path in which a battery, bulb, switch are connected through wire, which I just showed you, okay, where I had connected every component. Now different components are drawn to just show it, because practical drawing a bulb, a switch, three-dimensional figure is very difficult. So there is a circuit diagram, we call it as, in which we show the same components by simple lines and circles. So wire is shown by a line, resistor is something which I'll be explaining in coming videos. Light bulb can be shown like this or it can be shown like this. Okay. Cell, if it's one battery, then we show it like this. If I have to show two or three batteries connected, like I had connected two batteries, then it will be like this. When two cells are connected together, then that is it. Switch open is this, and if I want to show switch closed, then it should be closed like this. Okay. This is the different components of this circuit which are shown by a diagram. Okay, so if you want to see a schematic diagram of a typical electric circuit, we should be able to draw like this, switch, bulb, wire, and battery. It is very difficult as and when the circuit becomes more complicated, when more gadgets and more things are connected. So to make it more simpler and easy to understand, we have just changed it battery to its symbol, the switch into its own symbol, the bulb like this, and the wire as normal line. Okay, so this is the electric circuit, which shows the schematic diagram of what a circuit consists of, what all are connected together, and a diagram explains it, what is connected to which part of the circuit. Okay, now electric current. What is electric current? The rate of flow of electrons through a cross section in unit time is called as electric current. Means the number of electrons flowing through that particular part of the electric circuit in a particular unit time is called as electric current. Okay, now here it is electrons which are flowing. So the net charge is represented by Q. It's called as charge because electrons have a negative charge. The time T and current is I. Okay, so the formula for current is I is equals to amount of charge flowing in unit time. So net charge upon time taken. So Q by T. Okay, the unit for current is ampere. Ampere. Symbol is A. Ampere was named after the French scientist Andre Marie Ampere. Okay. So what is the definition of 1 ampere? It's the flow of 1 coulomb charge per second. How many coulomb charge? 1 coulomb charge passing through the current carrying conductor, that means a wire, in 1 second. So I is equals to Q by T is the formula. In that I'm going to substitute the values. So I is represented by ampere, which is 1 ampere equals to 1 coulomb charge flowing in 1 second or 1 minute. That is known as 1 ampere. Okay. The smaller units of current is, this is called as 1 milliampere, that is 10 to the power minus 3A, and this is 1 microampere, which is 10 raised to minus 6A. Okay. The instrument that is helpful in measuring the amount of current passing through this circuit or the wire is called as ammeter, and it's always connected in the series. Okay, let's again connect the circuit with the ammeter and see what happens and how much current it shows in the reading of the ammeter. Okay. Okay, so now again we are going to connect a circuit. Okay, by again here the only difference is we are going to connect an ammeter to it. I'm going to use a 3 battery. Okay, I'm going to put my bulb. I'm going to put the switch somewhere here. Let me put the ammeter. Okay, let me put it next to this one. Okay, let's connect it with the battery, the wiring. Let's do it quickly. Okay, this one here. Sorry. Sorry. Okay, so let's connect it and see what happens and what is the ammeter reading shown. So can you see 2.70? That's the amount of current passing through it. 2.70 ammeter, right? So let's do one quick thing. We'll remove one of the batteries and see what is the amount of current flowing. Okay, that's it. That's it. Just remove that. Just connect it. Okay, let's start. That was 2.70, right? Now, how much? 1.80. The moment the battery was removed, it's 1.80 ammeter. Can you see the reading here? Okay, let's do a quick thing. Let's remove one more battery. Okay. Okay, let's see. 0.90 ammeter. And can you see the brightness of the bulb? It's so low, right? So let's quickly add on the 2 batteries and see again what is it. Okay. Okay, so what is it? 2.70 and see the brightness. Okay, so hope you are clear with what is the circuit and why it is called as electric current, because the electrons flow through the circuit. It's a continuous closed path. The electrons always move from the positive terminal to negative terminal. We normally take it that way only, but inside the circuit, it's from negative terminal to positive terminal. Hope it was helpful. Thank you.